Okay, class, this is a little video I'm making to help you better understand distributive property. And this is the beginning of our Unit 1, okay? So let's take a look and let's explore some ideas here before we start. Some of you might have already seen distributive property, but I want to start from the very, very beginning. First, let's just explore this idea of the distributive property, okay? Okay, so let's just explore this idea. If I was multiplying, let's start with something very, very simple. If I was multiplying 2 times 6, we know that 2 times 6 equals 12, right? So that's a very simple concept. We know how to multiply two numbers. But how about if I want to write 6 in a different way? And we learned this in elementary school, but we never understood why were we writing 6 in a different way. What if I want to write 6, I still want to multiply it by 2, but what if I want to write 6, I'm going to put in parentheses because I want to write 6 in a very different way. I want to write 6 as 2 plus 4. 2 plus 4 is still 6. I just wrote it in a different way. Would I still get 12 if I multiply them? Yes, if we use the distributive property. And the distributive property says if you want to multiply and get exactly the same result, you need to multiply 2 times 2, okay? A positive times a positive, positive 2 times positive 2 equals a 4, okay? And then 2 times a 4, so positive 2 times a positive 4, that equals a positive 8. And then together, when I add this 2 number, it equals 12. So as you can see, I wrote 6 in a different way. I used the distributive property, and I still got exactly the same answer. What we need to pay attention is positive times positive gives us positive, okay? A positive 2 times a positive 4 gives us a positive 8. And 4 plus 8 equals 12. So we got exactly the same answer, writing a 6 in a different way. Would have worked if we wrote 2 times, let's write a 6 in a totally different way. Let's write 6 as 3 plus 3. So 3 plus 3. That's still a 6. I should end up with a 12 still. So if I use the distributive property correctly, I would do 2 times 3, positive times positive is 6, positive 6, and 2 times a 3, a positive 2 times a positive 3, that is also a 6, and 6 plus 6 equals 12. So again, 6 is written in a totally different way, but it still gives me the same results. And it would work in any way I want to write 6. I could write 6 as 1 plus 5, would still work. Okay, so this is what the distributive property does with numbers. Can we apply this property now that we are in a much higher math? Can we apply this property, distributive property, to variables? We sure can. So let's apply the distributive property. I'm going to write distributive property. I'm just going to abbreviate. Let's apply the distributive property to variables. Now remember, variables are just a letter of the alphabet that we use to represent a number, an unknown number. We don't know what that number is, so we pick a variable, a letter of the alphabet, X, Y, Z, any letter to represent. So here's an example. Here's an example. I'm going to still stay with number 2. We'll change to something else in a little bit. 2 times, let's pick the letter X. It represents some unknown number. We don't need to know what it is. And let's do minus, let's pick another variable, Y. There we go. So these two numbers over here We have no idea what they are. They could be a 3 plus 3. They could be a 2 and a 4. They could be any number, a 10 and a 6. We don't know. We really don't need to know. As long as I use the distributive property correctly, I should be able to simplify this and rewrite it in a different way. So using the distributive property, I'll multiply 2 times x first. Positive 2 with a positive x will give me a 2x. Okay? Now I just need to finish it. 2 times a negative y. So positive 2 times a negative. Positive times negative is negative 2y. Okay? So we just have to remember, let's make a little tiny note here on the side so we don't forget. A positive times a positive equals a positive. A negative times a negative will also equal a positive. So I like to remember, same times same, it's positive. Same times same, they're the same signs, stays positive because they're the same. If I have a positive times a negative, then we will get a negative. Different signs multiplied gives me a negative. Okay? So remember those 3 little rules right there, and your multiplication should always come out correctly. Positive times positive, it's a positive 2x. We're multiplying them, so that's why there's 2 times x. Okay? Let's do another example to make sure we really understand it. And this time, after I write the example, I would like you to pause it, try it by yourself, and then continue. Okay? Let's do 3 times a 3 minus, I'm going to pick a letter a for my variable. Okay? So pause it and try it. And you should come back and now check the answer. So let's see. 3 times 3, they're both positive. 3 times 3 is 9. And 3 times an a, but that's a negative a, okay? Positive times negative, different, we get a minus. And 3 times a is negative 3a. So that's the answer right here for this multiplication right there, okay? So that is what the distributive property we're going to be using here in the worksheet 1.1 for distributive property. So let me see if there's one more example we can do here. I want to make it a little bit more tricky. The last one I want to use is a negative invisible one. We never write, if it is a number 1, we keep it invisible. I'm going to write a negative x and a negative 5. So I have a negative number, I have no clue what this number is, minus a 5. What would I get from here? This is the challenge. I really would like to see what you get. So try it for yourself and then check your answer. Okay, so let's see. A negative 1 times a negative 1 in here becomes positive. Positive x. So negative times negative, positive x. And a negative 1 times a negative 5 becomes a positive 5. And that is our final answer. So I just simplify this to x plus 5. And there we go. Okay? So that's correct. And I'm pretty sure if you keep practicing, remember these 3 little rules right here, you'll be okay. Now, besides the distributive property in here, we also want to do, can we undo the distributive property? So let's explore undo. Can we undo the distributive property? Can we work backwards? That's a question that if you can multiply it, you can also separate and divide it out. So it's kind of like knowing how to pull that number. In here, we multiply the 2 into the problem. Can I see that 2 and pull it out? So let's take a look at it. It's kind of like that, but we are going to be faced with fractions. So let's take a look over here. And the problem asks us rewrite or write the following as a sum or a difference. So they're going to give me a problem. Let's create an example right here. Let's do 3x minus 2, all that divided by 2, okay? And it's asking us, write the following as a sum or a difference. So sum is an addition and difference is a subtraction. Over here, when I look at this problem, I don't have a sum. I don't see an addition anywhere. I have a difference. And I want to rewrite it as just a number minus another number. So let's see what we can do here. This numerator, there's two items in my numerator. I have the 3x. If I cover it, you see just the 3x. And I also have a negative 2. So I have two items in my numerator. I'm going to use a different color pen here. I have this item in my numerator, and I have this other item in my numerator. I have two of them. So to separate these two, each of them is going to get their own denominator. They're both sharing a denominator right now. We want them to each get their own. So I'm going to have 3x get the 2 denominator, and the negative 2 also get its own denominator. Okay? So I'm still dividing a 3x by a 2, and I'm still dividing a negative 2 by a 2. So these two statements right here, the left side is equivalent to the right side. They're both saying the same thing. Now, I'm almost done. I am writing as a difference. There we go. There's a number minus another number. I just have to simplify. Okay, now my next step from here to here, I just need to simplify if possible. If possible. Sometimes it's not. Okay? So if possible, I will try to simplify it. Let me see. A 3 divided by a 2, they're both already reduced. I cannot simplify this fraction. So I'm still going to leave it as 3x divided by 2. But a negative 2 divided by a negative 2, that is a negative 1. Okay? So there we go. I simplified it. It looks completely different, but it means exactly the same thing. Okay? I guarantee you, if you say, let's pretend x is a 2, it would work here. If you plug it in here, it would also work if you plug it in here. I promise you, these two statements are very, very, they're exactly the same. They're exactly the same statement. So there we go. We simplified it. Okay? Let's try one more. Let's try one more to make sure we understand it. Here's another example. And let's do 10y minus a 15 divided by a 5. So immediately you should see I have two separate items. This little subtraction is separating two different items. I have the 10y and I have the negative 15. Okay? So I have two separate items. The 10y is going to get its own denominator, 10y divided by 5. And the negative 15 minus 15 divided by 5. They each get their own denominator. And now from here to here, my last step is to simplify if I can. If I can simplify both, I will. Okay? All right. A 10 divided by a 5 is a 2. So I get a 2, and the y still stays there. Okay? 10 divided by 5 is 2. Minus a 15 divided by 5 is a 3. And there we go. We completely simplified it. We rewrote exactly what they were asking us. Rewrite as a sum or a difference. There we go. Here's my subtraction. Difference is written as a difference. Okay? So sometimes it's the denominators, as you notice here, one of them simplify, the other one did not simplify. That's okay. This next example, Both of them simplify. The two fractions were able to be reduced, and we got a nice whole numbers. Let's do one where both of them don't simplify it in the same way. So let's do one last little example of this kind of stuff. Let's do 10a, let's pick a different variable, plus 24, and let's divide it by 20. Okay? So immediately you should see I have my 10a. 10a is going to get its own denominator, and the positive 24 is going to get its own denominator. Alright, so 10a divided by 20 plus, there's a positive, 24 divided by 20. Okay? It's almost done. That is not the final answer. It wouldn't give you all full credit for all the points that you deserve. But let's simplify to the best of our ability. That will be my last step I need to do. Simplify. Okay? So let's see. 10 divided by 20. That is, you know, it's bigger denominator than it is in the numerator. So I have to reduce it. So I can reduce it by 0 first, right here. I can eliminate those zeros. And it ends up with 1/2. Or if you want to think it in a different way, this is divisible by 10, which it gives you 1. Okay, we divide it by 10. And this is divisible also by 10, and it gives us a 2. Okay, maybe that's the best way to think of. Okay, so I get 1 over 2. My variable still stays here, 1/2 times a, plus, now let's think of a number that we can divide both of these values by. Okay, so how about by, you can go by 2's. If you have a hard time dividing it, it's okay, go by 2. If I divide this by 2, I get a 12 divided by a 10. And you look at it and say, I still can divide it by 2 again. So divide it by 2 again. And 12 divided by 2 is 6. And 10 divided by 2 is 5. Then you look at it and say, can I go further? It looks like I cannot divide this by the same number. So you stop at 6/5, and that is what we get as simplified. So if you are afraid and you kind of like, I'm not good at simplifying, just start simplifying it slowly. I have no problem with you taking your time, slowly simplifying until you get to somewhere where you cannot simplify anymore. And then you're done. So we simplified this fraction that was all together, and we were able to undo the distributive property and come up with something that was just an addition. Okay, so there we go. We simplified it. They both look like two different numbers. We have 1/2 and 6/5. That's okay, and that is the simplification. Okay, the last thing I want to talk about in this video that is also part of 1.1 is combining like terms. Okay, so the last thing for this section is combine like terms. Okay, the terms have to be like terms. They have to be the same. Okay, they have to be same. They have to have the same variable. Okay, they have to have all the same qualities. For example, if I have, I'm going to start with something very simple. If I have 1x, and then I have 2y's, but then I have another 3 x's, and I also have another, let's do 4 y's. Okay, so this is all spread out. There are terms that are exactly the same. We have 1x in here, invisible 1, but I have another 3 of them over here. It's kind of like, okay, these guys belong together. I have 1x and 3x. I like to keep them together. So this and this guys right here, they are the same. So I'm going to combine them. I have 1x and 3x. That would equal 4 of the x's. Okay? Now I have 2y's plus 4y's. Well, I have a total of 6 of them. Okay, if I have 4 of them plus 2 more, I have a total of 6 y's. So we are just combining like terms. That's another skills that we must have before we continue in this unit. Okay, so I'm going to take a look at your worksheet, and I'm going to pick something very similar here for us to solve. Here was example 1. Let's do example 2. Okay, let's do 7 xy's, but let's subtract 2 xy's, but also let's add 3 xy's. Okay, and they ask me to simplify it. Can you please simplify this expression? I'm like, okay, so this is an xy, this is also an xy, this is also an xy. They're all the same term, so they are like terms, they're the same. So I can just combine them together. I have 7 of them, and then I subtracted 2 of them. So I like to take, they're all the same term, by the way. I like to highlight it. They're all the same. I'm going to take one at a time. I'm going to almost ignore that this 3 is there. Okay, I'm just going to take care of 2 of them at a time. So this 2 together makes 7 minus 2. So I have a 5xy. Okay, then I bring this guy down, plus 3xy. Okay, I just brought it down. And now I only have 2 more to take care of. I have a 5 plus a 3, so I'll combine this 2, and it's 5 plus 3 is 8 of the xy's. So we have 8xy. Okay, and that is the final answer. We simplified it. Let's do a little bit more challenging. Let's do a 4m squared n. Okay, I have a m squared n, and let's subtract a 3m squared n, and let's add a 6m n squared. Okay, so let's take a look at it, and let's see. I have a m squared n. Here I have a m squared n. These 2 terms are the same. So you look at it, this guy over here and this guy over here are the same. Here I have a m n is being squared. So this is totally different than this one right here. The m is squared, the n is not. Here the m is not squared and the n is. So this term, even though they all look the same, they are not the same. So I'm going to leave this guy completely out. Okay? I'm only going to combine the terms that are the same. So I have a 4m squared n minus a 3m squared n. So 4 minus a 3 is just a 1. We usually don't write the invisible 1. I'm going to put just a little shadow there that I'm writing a 1. So 4 minus 3 is a 1. If you want to write it, go ahead. And then you repeat the variable, m squared n. Okay? Plus, I got to bring this other guy down, plus this other guy comes down, 6m n squared. So this item, this variables here, had nothing in common with anybody else, so I can't add it to anything else. So to simplify it, we don't write number ones in front of variables. So we just keep m squared n plus 6m n squared. So I want you to see that these 2 things are completely different, okay? And that is our final answer. I combined the like terms. These 2 were the same, so I combined them to make 1. 4 minus 3 was 1, okay? So that is what we're going to be doing here also, is combining like terms. To the best of our ability, we're going to combine like terms, okay? And that concludes the lesson 1.1. You should be able to do all your homework in there, because that's all that I covered in here in this lecture notes. So good luck. Come and ask me for help if you need any. Okay, bye.